So time to put these things on the graph. We are going to learn some strategies in graphing quadratic functions, and we're only going to use one strategy. There are others in math, but we're going to use the table of values. Now, we used table of values when we were graphing linear equations, and they do take a little bit of work, but this is going to be our strategy. We're going to take a look at our equation. We're going to ascertain, we're going to figure out if it opens up or down. And so is it happy or is it sad? Is it a minimum or is it a maximum, right? And so that's the first thing that we're going to do. Then we're going to figure out the x of the vertex. And so what we were just using before was the vertex formula, right? To figure out the x. And then we were going to figure out the value at f of x. So take that x value and sub it back in for y. And so we get an ordered pair for our vertex. After we do that, we're going to start and make a table of values. We're going to go with 5 values of x with x as our middle number. And we're going to complete the values in the table for y and then graph it. So the first one that we have here is written in function notation, which is fine. F of x is y. The first thing we're going to do is figure out, is it positive or negative? And that's going to be a happy face, that we're going to have a minimum. The next thing we're going to do is figure out the vertex. So x is equal to negative b, which is 0, all over 2a. Right? There's a whole lot of invisible things going on with this. So we'd have plus 0x plus 0, and there's a 1 in front of there. So subbing into the vertex formula of negative b over 2a, this is what I get, which really just means that my vertex is going to be 0. Not undefined. This is 0 divided by a number. It's on, right? So my vertex is 0. Or technically, the x of my vertex is 0. So I can figure out the other part of my vertex, right? I could figure out the y value here, or I could also then go on and just fill out my x column. So remember, these are the ones that you choose, and these are the ones that you're going to solve for. So I'm going to pick the numbers that are smaller than 0, so -1 and -2, and then 1 and 2, right? If you want help, just look at your number line here. And now I'm going to go and solve all of these. And so if I were to, I'm just going to switch colors. I could start with my vertex. So I guess I'll just scroll a little bit. This is the beauty of function notation when you can't draw enough arrows to your chart. So I might start here. F at 0 would equal 0 squared, right? I went back to my original equation, getting rid of all the stuff that's invisible, to evaluate it at 0. So f at 0 is 0. That fills out the other part of my ordered pair, right? That's a point that's going to be on my parabola. I might start down here. I could do f at 1, right? So subbing in a 1 where I see an x. F at 1 is 1. That completes my ordered pair. I could do f at 2. So I sub a 2 in to my original. So that completes my ordered pair. And I could do the other ones as well. F at -1 would be -1 squared, or f at -1 is equal to 1. F at -2, sub -2 into my equation. F at -2 is 4. So really what I'm doing with this function notation makes it a whole lot easier than having to draw funny arrows in to fill these out. So these are all ordered pairs on my parabola. You'll notice that they're symmetrical, right? And let's put these on. So we've got 0, 0, I already did that one. I had 1 and 1, and then I had 2 and 4. Doing the other ones, I have -1 and 1, and I have -2 and 4. So this makes the pattern of a parabola. So mine are going to be a little messy. They're going to go on like that. Whoa, I'm sure you draw a much neater parabola than I do. But this is me taking this and putting it on the graph. We've got a number of these to try. They only get more complicated than that. My strategy is going to be the same for each one. So I'm going to start by deciding, is it going to be a happy face or is it going to be a sad face? This is going to be a sad face because I have a negative out there. I would have a maximum in this parabola. I'm going to start by figuring out my vertex, or at least the x of my vertex. The x of my vertex is going to equal -b over 2a. Now this one might also take a little bit of a look at what's invisible in here to see how this works. So we'd have -x squared plus 0x plus 3, right? So -b, you can't see it in the original, is 0 over 2a. X is equal to 0. And that's going to be my vertex. It's going to be the middle number on this column of x's that I get to choose. So in this one, I'm going to choose my values of x. So I'm going to go -1 and -2, and then go 1 and 2, making it symmetrical and using my number line as a guide. So I've chosen my values of x. Now I can get on to solving for all my values of y. So basically, I'm going to take each of these values of x and plug them back into my original equation. So I'm going to start with my vertex. It gives me a good place to start. So f at 0, and I also get to sub in a 0, which, you know, I love. Negative of 0 squared plus 3. Well, f at 0 is going to be 3. If you want to graph your ordered pairs as you go because you like that, go ahead. You can also do it at the end. The other ones I can work through. I'm going to go to the positive numbers first. I'm going to go f at 1. I would have negative of 1 squared plus 3. So f at 1, watch your signs, make sure you're subbing in with brackets. F at 1 would equal 2. So I can graph that on my ordered pairs, or I could just, carry on. I'm going to do f at 2 next. Negative of 2 squared plus 3. I get a negative, I have 2 is -1. And I'm going to keep going. By using this function notation, you can kind of write all over the page. So let's do f at -1 here. So negative of -1 squared plus 3. F at -1 would equal -1 plus 3. Oh, you should notice that they're symmetrical. Had you not made a mistake anywhere, you wouldn't even have to do the last one. But I'm going to do the last one because sometimes I make mistakes. And this gives me a chance to catch them. Also gives me a chance to show you subbing in with brackets. So evaluating the function at -2 allows me to complete this ordered pair. So f at -2 gives me -4 plus 3. Oh goodness, thank goodness, it's equal to -1. So these are all the ordered pairs. I started with my vertex. I could move on to this one, which is 1 and 2. Then 2 and -1. The next one would be -1 and 2. And you can almost do this without looking at them, but it's always a good check. I could graph my parabola looking somewhere. Whoa, missed it entirely. Like that. 5 points is adequate. As you can imagine, you could do a whole lot more, but 5 points gives me a chance to kind of see the general shape of this parabola. And I went to the bother of figuring out, is it going to be a happy face or a sad face first? You can, omit some of these if you're quite confident because of the symmetry in the y values. But I think, like I said, it's a good check. It's a good chance to catch your mistakes if you ever make mistakes, which I know I do. So this one's missing more of the kind of prompts, if you will. So we know that this is going to be a happy face one because it has a positive. We know that we're going to use the table method here. I'm going to start by figuring out my vertex, or at least the x of my vertex. So x would equal negative b, so negative of -6 all over 2a. So my vertex, or the x of my vertex, is 6 over 2, or x is equal to 3. So that's going to be the middle number here on my x column. So I'm going to pick numbers that are smaller than that and numbers that are bigger than that. Remembering that you get to choose the values of x, and now we get to solve for the values of y. Doesn't matter what order you do these in. You can start with the vertex, if you will. So I'm going to figure out the value of the function at 3. So I'd have 3 squared minus 6 times 3 plus 3. Oh my goodness, that's a lot of work. F at 3 would equal 9 minus 18 plus 3, which is, if I do this one right, -6. Use your calculator. I honestly just looked at my key. I wasn't about to do that one in my head. Okay, let's move on and do the bigger numbers, get those out of the way. So let's figure out the value of the function at 4. So what I'm going to do is plug a 4 in everywhere I see the x. Big numbers, but not hard. Use your calculator to help yourself out. What you'll get is the value of y when x equals 4. I'm going to keep going. I'll do the value of y when x equals 5. So using that function notation, because it helps keeps your page organized, I guess. And rewriting the function, subbing a 5 in for the x, I get 25 minus 30 plus 3. I get f at 5 is equal to -2. These other two should be the same as these two, right? But I'm going to keep going so that I can catch my mistakes if I made one. So I'm going to do f at 2 next to complete this ordered pair here. And so I would do 2 squared minus 6 times 2 plus 3. I get 4 minus 12 plus 3. I get f at 2 equaling, what is that? 7 minus 12 gives me -5. Ooh, things are looking good. And the last one, hopefully this one's easy. It's the smallest number that I get to sub in for x. I'd get 1 squared minus 6 times 1 plus 3. I get 1 minus 6 plus 3, or f at 1 equaling to -2. So I've completed my chart. Only thing left to do is to graph these things. If I start with my parabola, I usually do because it gives me a chance to see it. I know that I'm making a happy face, so I'll go to 2 and -5, like that. And what's the last one there? 1 and -2, or 5 and -2. And so graphing those 5 points, however you want to, whatever order you want to, gives me a chance, ooh, that one almost worked, to graph my parabola. And I'm sure you're much neater than me freehanding on this funky little drawing board that I have here. I think these are cumbersome. Hopefully they're not difficult. I am prone to making mistakes. I do like this strategy where we're going to take a look at this. I'm going to figure out how it looks. It's going to be a maximum. It's going to be a downward shaped parabola. I'm going to make my table. I'm going to know where to start my table by figuring out the x of the vertex. So x would equal -4 all over 2 times -1, or 2a. A. If you still want to list the A, B, and C on these ones, you totally could. Whatever keeps you from making errors, because if you get this wrong X, then everything's going to be off. So -4 divided by -2, or X is equal to 2. That gives me the middle point on my X list here. So I can go X is 2, 1, and 0, and then 2, 3, and 4, right? So now I can start filling out my Y's. I'm going to start with my vertex just because, no real reason. Negative of 2 squared plus 4 times 2 plus 2 equals -4 plus 8 plus 2 gives me a 6, I do believe. Oh, let's try that again. 10. Huh, something went funky there. Let me just check my work again. -4, 8 and 2, so 10. Oh. Oh, there, I copied it wrong. I was like, something is going wrong. See, I copied it right there. That's a 4. Okay. Whew. Is not 6. Not 6 at all. How about an 8? All right. Sorry for that. An 8. I'll keep going on, hopefully not making mistakes. Let's go up here. So we've got f at 3. So -3 squared plus 4 times 3 plus 4, copying that correctly. I'd have -9 plus 12 plus 4. Throwing that into my calculator, f at 3 is equal to, I shouldn't even be trying to cross-reference here, 7. Let's keep going on to the 4. So figuring out the function when x is equal to 4, negative of 4 squared plus 4 times 4 plus 4, that's a lot of 4s, equaling -16 plus 16 plus 4. So f at 4 is 4. And these other two should be symmetrical, but I'm going to keep going just because, as I've demonstrated, I make mistakes. So I get that, oh, good, f at 1 is equal to 7. And again, I'm hoping that they check out. And now I get to sub in a 0. I sure love subbing in zeros. All goes away. F at 0 is 4. And again, that checks out. Not necessary to do 2 of these, but I do think it's good practice. I'm going to start with my vertex. So 2 and, oops, it's off the page, right about there. We can pretend. We've got 3 and 7 and 1 and 7. We get 0 and 4. And we should have 4 and 4. Awesome. So we do have a downward shaping parabola like I had projected or predicted, and those should be enough to give me, enough anchor points to draw or conceptualize this quadratic equation. Let's hope for some smaller numbers in this one. In this one, I'm going to use the table method to graph this. I get to choose the values of x, but knowing what to choose, I'm going to use my vertex. So x would equal -b over 2a. X is equal to -2 over 2 or -1. And that gives me the central number on my x column. So smaller than that would be -2 and -3, and bigger than that would be a 0 and a 1. So I'm going to start by figuring out the other part of my vertex, the y value of my vertex. I'm going to sub a -1 in wherever I see the x. Whoops. So I'd have 1 minus 2 minus 1. and f at 0 would equal -2. Carry on. I'm going to go down here because I love subbing in zeros. We'd have 0 squared, f at 0 equals a -1. Continuing on, I'll do f at 1. It's kind of smaller numbers. 1 squared plus 2 times 1 minus 1. I'd have 1 plus 2 minus 1. I get f at 1 equaling 2. And I'll do the other ones just to round this one out, making sure I haven't made a mistake in my points. So -2 squared plus 2 times -2 minus 1. I get 4 minus 1. F at -2 should equal -1, which is good. That's checking out. And then f at -3, I could guess, but I'm going to take the time to sub it in. That's a 9 minus 6 minus 1, or f at -3 is equal to 2. So now that I've got all these ordered pairs, I can put them on the graph. I could go -3 and 2. I'll just read from the top this time. -2 and -1. My vertex, which is -1 and -2. 0, -1, and 1 and 2 for that symmetry around x equaling -1. And that would be my function graphed. 2 more to do. If you want to challenge yourself, give them a try. And then fast forward the video to see if they look the same, or use the answer key if that's what you'd rather. This one's going to be an upward shaping parabola. I think I forgot to do that on the last one. We're trying to figure this out with the table method. So knowing where to start, I'm going to use my vertex, or at least the x of my vertex to start. X would equal -b, so -6 over 2 times 1. That's going to give me an x value of -3 for my vertex. That's the central figure in my x column. So smaller than that would be a -4 and a -5, and bigger than that would give me a -2 and a -1. That is a lot of negatives to sub in here. Okay, let's start with my vertex. So f at -3 gives me -3 squared plus 6 times -3 plus 9. 9 minus 18 plus 9. F at -3, all that work, is 0. Okay, let's do the next one. Let's go down to the smaller numbers, just because I want to. F at -2, reading back to my original function, subbing in a -2 wherever I see that x. I'd have 4 minus 12 plus 9. Throwing that into my calculator, f at -2 is equal to 1. Okay, let's just keep going on these ones. So let's do f at -1. I'd have -1 squared plus 6 times -1 plus 9. You get 1 minus 6 plus 9, or f at -1 is equal to, what is that, 4? Is that right? Oh yeah, 4. So arguably, if I haven't made a mistake on the last two that I just did, I wouldn't have to do -4 and -5, but I'm going to, just to illustrate that we're all in this together. It's very cumbersome. Using your calculator, f at -4, it's a whole lot going on. Oh, that's equal to 1. That's good. And then the last one, maybe I'll do it up at the top here because I'm running out of space. F at -5 is the last of the ordered pairs to complete. So -5 squared plus 6 times -5 plus 9 gives me 25 minus 30 plus 9. And again, this is symmetrical. It all checks out to be 4. So graphing this at -5 and 4, -4 and 1, -3 and 0, -2 and 1, and -1 and 4. Gives me 5 points to anchor the drawing of my parabola. Last one. I gave us a different graph for this one because it wasn't fitting on very well. So hopefully this one works. Oh, you know what? I still don't think it fits on very well. That's okay. So we're going to use the table method. Central to this concept of the table method is knowing where to start. So I'm going to start with the x of my vertex is -b all over 2a. So we've got 6 divided by 6, or x equals 1. So that's going to be the central number on my x column. Smaller than that, I'd have a 0 and a -1. And bigger than that, I'd have a 2 and a 3. So now I have this laborious work of figuring out all of the y values. I'm going to start with my vertex for no real reason. You can start anywhere you want. That'd be 3 minus 6 plus 5. F at 1 should equal 2. All right, let's go up this time. That 0 is very attractive to me to sub in. I would get a 5. I'll show you how I can see it. F at 0 is 3 times 0 squared minus 6 times 0, all of which is nothing. Oh, there's the plus 5, right? So F at 0 is 5. And if I carry on, let's go up. Let's finish up here. So we'd have F at -1. I'd have 3 times -1 squared minus 6 times -1 plus 5. I'd have 3 plus 6 and plus 5. I'd have 14. This is where my graph paper became challenging. And I tried to save it by putting a bigger one in, and it's still not going to fit. I can also go the distance here. I could figure out F at 2. 3 times 2 squared minus 6 times 2 plus 5. I'd have 12 minus 12 plus 5, or F at 2, this is checking out, is 5. It's good because it's symmetrical, right? And the last one here to do F at 3. So I'd have 3 times 3 squared minus 6 times 3 plus 5. That minus is hard to see in there. I'd have 9 times 3, which is 27, minus 18 plus 5. And that gives me 14, or F at 3 is equal to 14. So all of these, if I were to put them on the graph, let's go -1 and 14, which isn't really working for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 13, 14, right there. 0 and 5. 1, 2, 3, 4, 5. Our vertex, which is going to be a minimum, this is happy face, of 1 and 2. And then these should be symmetrical. Way the heck up there. Close counts. We're trying to just sketch this and get an idea of where it is, but that would be my final one, kind of on the XY coordinate plane.